Hello, my wonderful students. You're welcome to another edition for Eko Learners Support for WAEC and NECO candidates. I remain your chemistry instructor, Mr. Oluwaleke Animation. Today we have another wonderful topic we're going to be treating, which is electrolysis of some compounds. Yes, sit back, relax, and go on this journey with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So at the end of this lesson, we should be able to explain the electrolysis of some compounds. First one is acidified water, and the second one is brine. Brine simply means a concentrated solution of sodium chloride. Electrolysis of acidified water dilutes tetrasulfuric acid. The electrolytic cell or apparatus used in this electrolysis is the Hofmann voltammeter. The electrodes used are the platinum foils. These are the ions present. H2SO4 dissociates into 2H plus and SO4 2 minus, and water dissociates into H plus and OH minus. So these are the cations and anions present in the solution when this acidified water is undergoing electrolysis. As we all know, the positive ions will run to the negative electrode, which is called the cathode here. While the negative ions will run to the positive electrode, which we call the anode in electrolytic cell. So the negative electrode is the cathode, and the positive electrode is the anode. The reverse is the case for the electrochemical cell. So, coincidentally, our cations in this solution is just a particular one. They are not two, they are not three, just one, which is what? Hydrogen ion. So there is no competition. There is no competition. So hydrogen moves to the what? Cathode, and it's deposited. The hydrogen ion moves to the cathode and is deposited as hydrogen gas. So this is the equation of the reaction. So if you remember from our previous classes, this is a reduction reaction because there is gain of electron. So that means reduction occurs at the cathode. Please take note of these little bits of points I'm giving to you. I said before that the cathode is negative electrode. The positive ions run to the what? Cathode doing the electrolysis. Now, I've said another thing again, that reduction occurs at the cathode. As you can see, there is gain of electrons to form hydrogen what? Molecules. So hydrogen molecules is formed at the cathode. At the anode, we have two things competing there. We have the SO4 2 minus and the OH minus. Both of them migrate to the anode. Why do they migrate to the anode? Why don't they go to the cathode? There are some questions as simple as that in WAEC objective. It will ask you which electrode does this particular ion go to. So, as I've said earlier, the negative ions move to the what? To the anode. That's why they are called the anode ions, anions. Anions. Now, this rhymes. Anode, anions. What the previous one we said was cathode, cations. The cations go to the cathode, cat. While the anions move to the anode. So get this into your head so you don't forget it. So the anions move to the what? Anode. Now, the anions are negative. So, because sometimes if you forget that the anode, is it positive or negative in an electrolytic cell? If you remember that the anions are negative and they have to move to the anode, that means the anode cannot be negative, because surely it's only a positive electrode that can attract the negative ions to itself. So that is why they move to the anode. Now, when they move to the anode, one of the factors that affect the discharge of ions in electrolysis, as we all know, is the position of ion in the electrochemical series. So OH minus and SO42 minus, after migrating to the anode, is only one of them that will be discharged. And that one that will be discharged is OH minus. It's OH minus that will be discharged. And that's how the reaction goes. OH minus will be discharged in form of oxygen. It will be discharged in form of oxygen. The reaction can also be summarized like this, for OH minus to give us so the reaction can also be summarized like that. So, but this is the steps in breaking it down. OH minus gives you OH. OH plus OH gives you water plus 1 atom of oxygen. As you know, 1 atom of oxygen is not possible. So it has to combine with another atom of oxygen to give us oxygen gas. Before this can come into play, that means these sets, we have to react again. So that's why it's a total of 4 OH minus. So at the end of the day, oxygen is discharged at the anode, while hydrogen is discharged at the cathode, as we have seen. So this is a summary of the reaction. This is summary of the reaction. So the overall reaction, 2 volumes of hydrogen are produced at the cathode and 1 volume of oxygen at the anode. The discharge of OH minus at the anode disturbs the ionic equilibrium of water, hence more water molecules ionizes to restore the equilibrium. So what are they saying here? When OH minus is discharged, so water must dissociate again to replace the lost OH minus that has been discharged. That's why more water molecules ionizes. So the overall result of that is that the total amount of acid in the solution remains unchanged and its concentration increases due to the removal of water molecules. Because as the level of water reduces, the concentration of the acid increases. So that is what we have on that side. That's the Hofmann's voltameter. As you can see, as we have said before, we have 2 volumes of hydrogen as compared with 1 volume of oxygen. So this is what we have said before. Oxygen is discharged at the anode and hydrogen is discharged at the cathode. So the next one is electrolysis of concentrated sodium chloride, which we refer to as brine. So how do we carry out? We have the anode, we have the cathode, we have the ions present, NaCl in concentrated form, and this is what? H2O. When we say concentrated sodium chloride, that means the water is little, the salt is much. So NaCl dissociates to give you Na plus and Cl minus. Water dissociates to give you H plus and OH minus. Unlike the previous one we did, this one has 2 distinct cations as well as 2 distinct anions. So how do we carry it out? Let's move on. So this is a diagram showing what happens during the electrolysis of brine. It's a diagram which shows us what happens during the electrolysis of brine. Chlorine gas is produced at the positive electrode, which is the anode, while hydrogen gas is produced at the negative electrode, which is the cathode. How does this occur? Why is chlorine gas produced? Why is OH minus not discharged, like we did in the previous example during the electrolysis of acidified water? Why is it chlorine gas now? We'll get to know that. Here, hydrogen gas is what is formed. Why is hydrogen gas formed? We'll also get to know that. So this is brine. Brine is sodium chloride solution. When sodium chloride is dissolved in water, its ion separates and can conduct what? Electricity. Here it is being stated that the chlorine gas that is evolved is used to disinfect swimming pools. So our swimming pools that we swim in, chlorine is used to what? Make it better. While sodium hydroxide that is left in the solution is used to make soap and used to clean what? Ovens. Why is sodium hydroxide left in the solution? We'll get to know all this very soon. Now, at the cathode, we have two competing ions. We have Na plus and H plus. Both of them migrate to the cathode. Who is going to be discharged? Is it sodium ion and hydrogen ion? Remember that reduction occurs at the cathode. Reduction occurs at the cathode. If you look at our electrochemical series, the distance between sodium and hydrogen is far. So sodium is very, very electropositive, while hydrogen is not as electropositive as sodium. Hence, that is the reason why hydrogen is going to be discharged at the cathode, despite the concentration. Despite the concentration. Because concentration of an ion favors its discharge under one condition: when the distance between it and the competing ion is very little. The distance is very little. Probably one ion is separating them or two ions is separating them. But when the distance is very far, just like it is for sodium and hydrogen, then it is hydrogen that will be what? Discharged. So hydrogen is discharged here. And of course, hydrogen cannot stay alone. So hydrogen will pair with an hydrogen to give you hydrogen what? Gas. At the anode, Cl minus and OH minus migrate to the anode. If Cl minus and OH minus migrate to the anode, what happens? They will compete to be what? Discharged. Now, it is meant to be OH minus. OH minus is meant to be discharged. But Cl minus is greater in concentration. Not only greater in concentration, it is also close in proximity to OH minus in the electrochemical series. So they are very close to each other. So that is the reason why Cl minus will be discharged. Remember, students, I told you here that Na plus 2 is also what? More concentrated than H plus. But the reason why it is not being discharged, despite its high concentration, is because the distance between it and hydrogen ion is very far, is wide. But in this case, the distance between Cl minus and OH minus is not much. So that is why Cl minus will be discharged. As you can see, chlorine is discharged. Cl plus Cl to give us what? Cl2. Note this, students, platinum anode must not be used in this electrolysis to prevent the attack of platinum by chlorine. So chlorine attacks platinum, hence platinum anode is not what? Used. Just like oxygen attacks carbon, graphite. So in your choice of electrodes, platinum is not used in this electrolysis. Also, it should also be noted that some discharge of OH minus occurs in this electrolysis. Yes, just a little. But majorly it is what? Cl2, because chlorine is the one that is favored because of its high level of what? Concentration. So this is a summary of the reaction. As we have said, hydrogen is discharged at the cathode, and chlorine is discharged at the anode. So this reaction alone tells us that reduction occurs at the cathode and oxidation occurs at the anode. Now, let us practice this question, students. Please, let us read it, let us go through it, prefer solutions, and let's get back to the class. Let me give you some time. Yes, we are welcome back, students. So what is our answer? The first question says concentrated sodium chloride solution was electrolyzed using graphite electrodes. Now this is a GCA question, question 5C. We're asked to state the ions present in the solution before electrolysis. The ions present in solution. This is exactly what we did. Electrolysis of brine. So we have done it. So I believe our students at home all got it. The ions present in the solution before electrolysis are what? Very good. As we all know, sodium chloride will dissociate to give you sodium and chlorine, and H2O will dissociate to give you H plus and OH minus. So the ions present are these. You are very correct, my wonderful students. So this is what is present before electrolysis. The next question says, name the product formed at each electrode. Wow. The examiner does not know that you have been properly taught. Which product is formed at each electrode? Remember, these two goes to the cathode. These two goes to the anode. Despite the high concentration of this, remember, we are dealing with concentrated, the word concentrated. Hydrogen ion is still discharged. So hydrogen is formed at the cathode and chlorine is discharged at the anode. Hydrogen is formed at the cathode, chlorine is discharged at the anode. So that's very correct. Write the balanced chemical equation at each electrode. I believe we already know this. It is what has been displayed to us, what has been taught to us. So the balance what reaction. Our hydrogen and chlorine is what's being formed. Thank you very much for your good responses. What will be the effect of the solution left after electrolysis on methyl orange? This looks tricky. Remember, this goes off the solution. This also goes off the solution. So my fellow students at home, what remains? Guess it's as good as mine. Sodium hydroxide remains after the electrolysis. So if sodium hydroxide remains after the electrolysis, so what is the effect of methyl orange in sodium hydroxide? So it turns methyl orange yellow because it's a base. It turns methyl orange yellow. That's very good of us. The next question says, state on a large scale use of the solution after electrolysis. So sodium hydroxide, we all know that it is what? It is used in making what? Soap. That's a very, very important use of sodium hydroxide. So it is used in making soap. So this brings us to the end of our lesson. Remember, I always say we should practice and practice always so that we become better.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
You might not know if you have any question suggestions, reactions, please feel free to reach us on the link displayed on the board. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.